Hello everyone. So today I'll be showing how to use the autoPA add-on for the track and mount. In this case, I'll be showing how to use 3-point polar alignment with Nina. Um, and one of the main requirements right out of the gate is to have plate solving. So you definitely need to have everything configured in Nina before you can do anything at all. And of course, have the 3-point polar alignment add-on already installed. And also, there's a setting on the add-on that you need to have enabled as well. So the plugin or executable file that we use for the autoPA will be able to work. So in this case, what you need to do is you need to look for the add-on on the store here, if you want to call it that, and then install it, restart Nina, and then the only thing that you need to do is look for the add-on, and you need to enable the log. Let's see this one, this option in particular, log polar alignment error adjustment. So that's the one you need to turn on, so the plugin that we use will be able to read the log file and do the necessary corrections. So then the next thing you need to do is go to imaging and then select 3-point polar alignment. The beauty of this is that you can start from almost anywhere in the sky. You don't necessarily have to be looking at the Polaris or any other star like that. You can point it to almost anywhere in the sky, and we have plate solving. It should be able to polar align itself. So in this case, I also wanted to show another add-on for the mount, which is the OAT simulator. So in this case, this will give you a 3D view of the mount and where it's looking at. So in that way, you don't have to go outside and see, oh, maybe it's about to crash with something or something else is happening, right? So you can do this directly from here. So in this case, I pointed up, so we can do the 3-point polar alignment. So let's get started with that. So another setting that you need to select is this one. Start from the current position. So then you click on the play button here. So it's going to take an image. It's going to play solve it. If we can play solve it. As you can see, there are some clouds in there, which might create some issues. So, okay, so there we go. So we saw the first image. So what it will do next, it will rotate the mount on its own. As you can see here from the simulation, is doing just that. So now it's going to take a second image, solve it, and as you can see, it rotates again. It's going to look for the final image. So yeah, there's definitely some clouds in there, but I think we should be all right. Okay, perfect. There we go. So now we have the total error. Either will tell you to move the mount right, in this case east or west, move up or down, and as well, this will be assuming that you are at the back of the mount, so you can make these adjustments. If you don't have the autoPA add-on, you can definitely do this yourself manually, rotating just the front of the mount or moving up and down with the screws, with the rear of the mount. Um, it's a little bit difficult because you have to be very precise to do these adjustments, but you can definitely do it. So in this case, I'll show how to use the add-on. So in this case, I select Nina from this drop-down menu. There is a different version, if I'm not mistaken, of this file, but the process is the same. So in this case, I will define the precision that I want. I want 30 arc seconds, and the only thing that I have to do is just click on Start. So what this will do, it will read the log that Nina has created, and it will start moving the mount. So in this case, I have a dedicated Astro camera, but if you're using a DSLR, then it will take dozens of shots, hundreds perhaps. I don't know if you've been paying attention so far, but it has been taking, I don't know, maybe 20, 30 already so far. So you can imagine your shutter count will definitely increase, right? So this is what the advantage, I will say, of an astronomy camera as well. So you don't have to worry about those things. Um, but it's definitely doable with the DSLR, no doubt. So it looks like we run into an issue right now, um, which is the clouds. Let's see what happens now. Okay, looks like it's doing the first correction. As you can see, the stars start to trail and the total arrow went down. I think it was like 2 something, 2 degrees. So it keeps going right now. Hopefully the clouds will allow us to finish this process. Okay, looks like we're definitely going down. And on the right hand side, you can also see the output that the uh, program is generating. So at least we have an idea of what's going on if we don't see like any movement or anything. Let's see what's happening. All right, so I had to pause the video for a moment. Those clouds were still getting in the way, and it looks like they still are. But as you can see, um, we're definitely getting closer to the error that we set earlier, to the maximum error, acceptable error that we set earlier. So we're definitely getting there. All right, that was pretty good. It's bringing us step by step closer to what we need to do. That was pretty good. So typically, this process will take, I will say, maybe 1 or 2 minutes, something like that. Um, when there's no clouds, of course. Um, and there's also a setting in Nina that you can enable, so you can tell it what is the acceptable total error that you would like to have. In my case, I think I set it to 1 arc minute, if I'm not mistaken. Because if not, if you don't set that, then it will keep just taking shots until the end of time, basically, until you stop the process, right? So in this case, it will stop the process automatically once it reaches to 1 arc minute. And unfortunately, it looks like the clouds are still getting in the way. So hopefully they will go away soon enough. All right, so you can see the process already stopped because in this case we reach the value that I said earlier, which was in this case 1 arc minute, if I'm not mistaken. And you can see what was the total error at the end. which is pretty good. And then the next thing to do here is you can close this window, and that is it. You got already polar align without too much hassle.